Hi, welcome to Python Polygon. Today's topic is going to be permutations, combinations, and probability. Okay, so basically, it is like two different topics: permutations and combinations, and probability. But one cannot go without the other. Okay, so in probability, you use a lot of permutations and combinations. Hence, it is always taken together. Okay, fine. Let's understand what is permutation. Permutation is an arrangement of objects when the it's a collection of objects basically. Okay, when the arrangement, that is the order of the objects matter. Okay, we'll understand what it is in the questions. Okay, I think most of you might be knowing what permutation is. So there are a few important say properties or something that we'll use in the problems. Okay, and combinations is when the arrangement does not matter at all. Okay, so here there are a few other properties also, so we'll go with that in the questions. Probability is how probable a certain event is of happening. Okay, so basically you always have a sample space for probability. Okay, to find out the probability of one event you need a sample space for the event, and then you need favorable cases and non-favorable cases. Okay, so basically probability, this comes from set theory. Okay, p of a or b is given as probability of a plus probability of b minus p of a and b. Okay, similarly probability of a and b can be written as p of a into p of b given a. This is something called conditional probability. Okay, conditional probability is probability of B happening given A happened. Okay, that is how it's read, and that is what it means. Okay, so this also conditional probability P of A given B is equal to P of A and B. A and B is nothing but A union B divided by P of B. Okay, sorry, A and B is A intersection. Okay, and is intersection or is union. Okay, then remaining will deal when the question comes. Okay, we'll come to the questions. How many ways can a six-member team be formed having three men and three ladies from a group of six men and seven ladies? Okay, so basically we know that the arrangement doesn't matter here, right? So if we take A, B, C, or if we take C, B, A, they're all the same team, right? So arrangement doesn't matter. Hence, it's a combinations question. Okay. So first is identifying whether it's a combination question or a permutation question. Okay. Now that it's a combination question, what do you have to select? You have to select three men from six men. So it comes as 6C3. Okay. Immediately it comes as 6 choose 3 plus is it a plus or is it a multiplication? See, it is a plus when it is happening one after the other. It is a multiplication when the two events are happening simultaneously. So the selection of a man and the selection of a woman is happening simultaneously. Hence it's a into. Okay, so this 6C3 into, there are seven ladies, you have to choose three from them, so it becomes 7C3. Okay, this will come as your answer. So how to evaluate this is see, uh, those of you who don't know how to evaluate a choice C question, see, start from the bigger number, go down the number of steps that is there here. Okay, so 6 into 5 into 4, I went down 3 steps, and then divided by, go up 3 steps from 1. So 1 into 2 into 3. Okay, into 7C3 is 7 into 6 into 5 using the same logic, and 1 into 2 into 3. Okay, so both sides I can cancel 2 into 3 and 6. You are left with 20 into 35, that is 700. Okay, next question. What is the number of possible words that can be made using the word quiz? Okay, such that vowels never come together. Okay, if vowels come together, see, always never come together questions can be changed to another form. Okay, so I can write this as total combinations of quiz minus when the vowels come together. Okay, so basically I can write this like this, right? Because it's very difficult to count how many combinations are there when it never comes together. So we'll go with the opposite. Okay, so total comes as what? There are four spots. Okay, if there are four spots, the first spot can be occupied by four letters. This spot can be occupied by three. This spot two, and then this spot one. So it becomes 4 into 3 into 2 into 1. That is 4 factorial minus when the vowels are together. Okay, you have to always think of it like this: Q, Z, and then UI. UI is one block. Okay, so here there are three letters. Okay, so the combinations can come as 3 factorial. Okay, of these, but ui can be written as iu also, so there are two combinations possible, hence this will be 3 factorial into 2. Okay, so 3 factorial into 2. Here I can take 3 factorial common. 3 factorial is 4 factorial is nothing but 3 factorial into 4, right? So this becomes 4 minus 2, so that becomes 2 factorial. 3 factorial is 6, 2 is so into 2 is 12. Okay, so that is the answer. Simple. Next question. In how many ways can an interview panel of 3 members be formed from 3 engineers, 2 psychologists, 3 managers if at least one engineer must be included? Okay. See, again, at least questions can be converted into total, okay, minus no engineers. Okay. So the members are 3. If you have to select the total, okay, total comes as total number of members that are there. So there is 3 plus 3 plus 2, that is 8. Okay, from 8 members you have to choose 3, that is the total. Okay, this is again a choice question, obviously. If you have no engineers, then eliminate this. Okay, then you have 2 plus 3, that is 5. In that you have to choose 3 members, so that becomes minus 5c3. Okay, so just simplify this, you'll get the answer. 8 into 7 into 6 divided by 2 into 3 minus 5 into 4 into 3 by 3 into 2. Okay, so this is 10 and this is 8 sevens are 56 minus 10. So this is 46. So there are 46 ways to choose this interview panel. Next question. There are 5 floating stones on a river. A man wants to cross the river. He can either move 1 or 2 steps at a time. Find the number of ways in which he can cross the river. Okay, man can't take double steps from the last stone. So basically first we just draw a diagram. Okay, so this is the man. Okay, this is the first step, second, third, fourth, and fifth. Okay, and this is the river. I mean, this is the other part, the banks of the other part. Okay, and he is standing here. Now he wants to cross it. Okay, so we'll just note down the number of ways possible. Okay, so see, he can either do it in 1 steps or 2 steps at a time, right? So let's see, he can do 1, 2, 3, 4, 5, and 6. Okay, so he can do 6 ones. I'll just note it down. 6 ones, or he can do 1, 2, and then remaining ones. So this, and this. Okay, so 1, 2, and then 4 ones. Okay, this can be rearranged in many ways. That is 1, 2, 1, 1, 1, or 1, 2, 1, 1, 2, 1, 1. Okay, 1, 1, 1, 2, 1, and the last case is 1, 1, 1, 1, 2. Okay, there are 5 arrangements for this. Okay, there is one arrangement for this. Secondly, he can take a double step and then he can take a double step. Okay, so then he can take 2 1 steps. Okay, so that is another condition. So that will be 1, sorry, 2 2, then 1 1. Okay, these can be rearranged in see, there is 2 1 2 1, then you can write as 2 1 1 2. Then you can also have it as 1 1 2 2. Okay, then 1 2 1 2 and 1 2 2 1. Okay, so there are 6 possibilities for this, and then one last possibility is 2 2 and 2. Okay, so there is one here, one possibility here, 5 here, and 6 here. So the total comes as 6 plus 5 plus 2, that is nothing but 7 plus 6 is 13. Okay, so 13 is the total number of ways he can cross the river. Okay, that's all. Next question. In how many ways can alphabets from the word derail be arranged so that the vowels come at odd positions only? Okay, so D, E, R, A, I, L. Okay, odd positions is this, and this. Okay, the vowels are E, A, and I. Okay, so first we'll fill out the vowels. Okay, the vowels, here there are 3 options. Here there are 3 options. Here there are 2 options. Here there is only one option for the vowel to sit. okay? And then if you have to fill in the other letters remaining, here there are how many options? Three options. Here there are two options. Here again there is only one option, okay? So the total comes as 3 into 3 into 2 into 2. That is nothing but 9 into 4, that is 36. That's the answer. Next question. How many distinguishable permutations of the letters in the word banana are there? Okay. So for this, what you have to do is number of uh, total letters divided by repetitions factorial. Okay. So basically for banana, if you're trying, there is 1, 2, 3, 4, 5, 6. Okay. So there are 6 letters. So I have 6 factorial on the numerator. Okay. And I divide it by how many repetitions are there? So there are 3 repetitions for A. So I have to multiply 3 factorial into, there are 2 repetitions for N. So I'll multiply 2 factorial. Okay. So this comes as 6 into 5. 6 factorial can be written as 6 into 5 into 4 into 3 factorial. 3 factorial cancels. 2 factorial is nothing but 2. 2 cancels 2, 4 2 times. So this comes as 35, 30 into 2, 60. So that's the answer. Simple. Next question. An integer p is chosen at random from the numbers -3 to 3, both included. What is the probability that value of p is less than 2? Okay. See, it is an integer first of all, and closed brackets means the boundaries are counted. So the total number of possibilities are -3, -2, -1, 0, 1, 2, and 3. Okay. Probability that the value is less than 2 means it should be from here to here, right? It cannot be 2. So there is 1, 2, 3, 4, 5 possibilities. Okay. The formula of probability is basically favorable conditions by total number of conditions. Okay. So total conditions are 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay. So this is 7. And then favorable conditions are 1, 2, 3, 4, 5. Okay. So this comes as 5 by 7. The probability. Next question. A box contains 6 black, 5 brown, 2 yellow balls. If 2 balls are selected at random, what is the probability that both of them are black? Okay. So how many favorable conditions are there that the first ball is black? Okay. Here there are 6 black balls. Okay. You have to divide it by the total number of balls. So 6 plus 5 plus 2, that is nothing but 13. Okay. So the first block will be filled in 6 by 13 ways. Okay. And second one also should be black. That means the probability there is how much? Because it is not replaced, there are only 5 balls left. Okay. And you divide this by the total number of balls left. That is nothing but 12. Okay. And if you want to find the total probability, you just have to multiply because they have to happen at the same time. Okay. So 6 ones are 6 twos are. This comes as 5 by 26. That's all. Next question. A bag contains 21 balls numbered 1 to 21. Two balls are drawn, one after another without replacement. Find the probability that both the balls are even numbered. Okay. So between 1 and 21, how many even numbers are there? There is 2, 4, 6, 8, 10. Okay. 12, 14, 16, 18, 20. Okay. So basically there are 10 even numbers. Okay. And there are total of 21 balls. Fine. Now probability that the first one is even is how many favorable conditions? Is 10 divided by total conditions 21. Okay. For the second one, how many balls are left? There are 9 even balls left because one is already selected. Divided by how many balls are left inside the bag? There is 20 balls because one is already picked. Okay. So you have to just multiply this. So this comes 2 and you will get it as 9 by this you can cancel 3 times, 7 times. This 2 remains. So 3 by 14. That's the probability. Next question. A 5-digit number is formed using 1, 2, 3, 4, and 5 with no 2 digits the same. Okay, that means repetition is not allowed. What is the probability that the formed number is divisible by 4? Okay, so for a number to be divisible by 4, you need to have the last 2 digits divisible by 4. Okay, so if you want to form a number divisible by 4 in the last 2 digits, okay, so what we have to do, let's count the number of ways possible. So if you have 1 starting, so if this is 1, I can have 12 as a multiple of 4. Okay, nothing else is a multiple. So this it can end in this. Okay, One more way it can end is with a 2 first. So 24 is multiple. Okay. Then 32 is a multiple. So 3 and 2 is a multiple. Then there is 40, 42 is not a multiple, 41 is not a multiple, 43 is not, 45 is not. Okay. Then there is 50, 52, that is a multiple. Okay. So this much is a multiple. So now if I count how many ways are there are four endings, okay, possible. And here there will be one, two, three blanks, one, two, three blanks, one, two, three blanks, one, two, three blanks, where there are all three factorial options. Okay, so there are three factorial options here into how many possibilities are there? Four possibilities. So it will be 3 factorial into 4. Okay, so the answer will be this is 6, 6 4 are 24. Okay, so 24 number of favorable conditions. Okay, but what is the total number of conditions? Because we need probability, right? So probability is nothing but favorable by total. So total is nothing but 5 factorial, right? So this comes as 24 by 5 factorial. That is nothing but uh, 4 into 6 divided by 5 into 4 into 3 factorial. That is 6. 6 and 6 cancels, 4 and 4 cancels. So it will be 1 by 5. Okay, so 1 by 5 is the probability. That's all. Next question. A box having 5 black, 3 brown flags. Okay. Another box having 4 black and 6 brown flags. If one flag is drawn from each box, find probability that both the flags are of different color. Okay. So different color means it can be either black picked first and then brown picked. Okay. Or it can be brown picked first and then black picked. Okay. So we have to calculate the probability. If you have to pick black from the first box, so I have favorable conditions as 5, total conditions as 8. So this probability will be 5 by 8 into brown from the second box is nothing but 6 by 10. Okay. So I have to multiply this to get the total probability. That comes as 2 and 3, 3 by 8. Okay. Similarly, here if I have to pick brown first, this comes as 3 by 8 and this comes as 4 by 10. Okay. So if I multiply, I get this cancels to 2 times 3 by 20. Okay, so now I simply have to add the probabilities, right? So because it's happening two different times, okay, not at the same time. So I get the total probability as 3 by 8 plus 3 by 20, which is this 6 and this comes as 15. 15 plus 6 is 21. Okay, 21 by 40. That's the answer. Next question. Ram speaks truth 3/4 of the cases and Sham is 4/5 of the cases. In what percent of cases, while narrating the same event, are they likely to contradict each other? Okay, if they contradict each other, let's say Ram has to speak the truth and Sham has to lie. Okay, or Ram has to lie and Sham has to say the truth. This is the only two ways. Okay, so for Ram to speak the truth, he speaks the truth in 3/4 of the cases. So this probability will be 3 by 4. And for Sham to lie, this probability will be 1 minus probability of him saying the truth. That is 1 minus 4 by 5. Okay. And for Ram to lie, it will be 1 minus his probability of saying the truth. That is 1 minus 3 by 4. And Sham to tell the truth is 4 by 5. Okay. So I have to simply multiply this and this and this and this. And then add both of them because they happen differently. Okay. So I have to multiply 3 by 4 into 1 by 5 plus 1 by 4 into 4 by 5. Okay, 4 and 4 cancels. So this comes as 3 by 12. Sorry, 3 by 20 plus 1 by 5. Okay, that is 4 by 20. So this comes as 7 by 20. So 7 by 20 is the this thing, uh, the probability. So if I have to calculate the percentage, 7 by 20, I just multiply by 5 on top and denominator. This becomes by 100 and this is 35 by 100. So 35% of the times they contradict each other. Okay. Next question. Four different pens, 1, 2, 3, and 4, are distributed at random in four pen stands marked 1, 2, 3, and 4. What is the probability that none of the pens occupy the place corresponding to its number? See, for this problem, I can call, see, I'll just mark the stands as instead of 1, 2, 3, 4, I'll say A, B, C, and D. Okay. So let's say at place A, I fix the number 2. Okay, the pen number 2. Okay, so now I have to fill the rest, right? In C, I will fix the pen 1. Okay, so in B, I will fix the pen 3. I can't do this because it won't. It is D will go to 4. That is not allowed. So I will fix 4 here and I will fix 3 here. So that is one condition. Okay. Second condition is I can interchange these two because 4 and 3 don't matter. So 1, 4, 3 is one more condition. 2. Okay, and one more condition is 2. And then see, I can put 4 over here. I can put 1 over here, and I can put I can put 3 over here, 4 over here, 1 over here. Okay, so these are the three conditions possible. Okay, there are three cases possible. Similarly, this I can, for this, I can fix 3 or I can fix 4 also, right? So I can either fix the number 2 or 3 or 4. So here there are three conditions. Here there are three. So 3 into 3 will be the total number of cases. Okay, it's a little tricky to understand, but this is it. This is what it's going to be. It's going to be 3 into 3. So because I can fix either 2 in A, 3 in A or 4 in A, then I can count and find out I get 3 conditions each. So I get this as 3 into 3 divided by total number of conditions is 4 factorial. Okay. So this probability will be 3 into 3 by 4 into 3 into 2. Okay, so 3 and 3 cancels. This comes as 3 by 8. So that's the answer. Next question. This is the last one. What is the probability that a randomly selected bit string of length 10 is a palindrome? Okay, randomly selected bit string. For a string to be a palindrome, okay, first I will have the 1 2 3 4 5 6 7 8 9 10. Okay, 1 2 3 4 5 I will have a mirror. Okay, so whatever I fix over here, it has to like reflect on the other side. Okay, so I don't need to worry about anything on the right hand side, so I will only worry about this side. So I have two options here, either a 0 or a 1. Whatever I fix here will be reflected over here to make a palindrome. Okay, similarly I have two options here, I have two options here, I have two options here, and I have two options here. Okay, so I have 2 to the power 5 options divided by total number of options are if I have 2 here, 2 here, 2 here, 2 here, 2 here, so on. So that is 2 to the power 10, right? So this will come as 1 by 2 power 5 because it cancels. So this is 1 by 32. So that is the probability that the a randomly selected bit string of length 10 is a palindrome. Okay. So again, for a recap of this question, you fix a mirror here, only fix these 5 places. These 5 will be determined automatically. Okay, then only it will be a palindrome. Fine. So with this question, we come to the end of this topic. I hope you guys like the video. Thank you for watching. I will see you guys in the next topic.